Every year, billions of dollars are lost in construction projects worldwide. Not because of lazy workers. Not because of weak materials. Not because there is insufficient demand. The truth? Projects fail because of poor planning, weak systems, and unmanaged risk. A single miscalculated schedule can push a project weeks behind. A small budget oversight can turn a profitable project into a loss. And a single communication failure between the office and the site can create chaos that ripples through the entire project. Delays explode. Budgets spiral out of control. Teams miscommunicate. Clients lose trust. And reputations are destroyed. Small mistakes. They become massive problems. Imagine this: a contractor orders the wrong type of steel. It arrives 2 weeks late. The crane sits idle. Subcontractors wait. Concrete pours are delayed. Labor costs rise. And suddenly, what seemed like a minor oversight turns into tens of thousands of dollars lost, maybe even more. Construction doesn't fail randomly. It doesn't fail because of bad luck. It fails systematically. It fails when planning is weak, when control systems are absent, when risk is ignored, and when teams operate without structure. If you are a contractor, developer, project manager, or construction professional, you need a system. A system to plan projects accurately, control costs before they spiral, manage schedules that actually work, and handle risk professionally, every single day. Without a system, you are flying blind. And blind projects fail, every single time. This course is that system. It is a complete roadmap to manage construction projects from start to finish. From the very first blueprint, to budgeting, to scheduling, to risk management, to final handover. You will know exactly what to do, how to do it, and when to do it. By the end of this training, you will be able to predict and prevent cost overruns before they happen. Keep projects on schedule, even when unexpected delays occur. Coordinate teams so that everyone works in harmony. Identify risks before they threaten your project. Make decisions confidently, with systems backing you up. Construction is complex. Projects are dynamic. Mistakes are costly. But with the right knowledge, the right systems, and the right mindset, you can transform chaos into control. You can turn risk into opportunity. And you can consistently deliver projects on time, within budget, and with high quality. So if you are ready to stop losing money, to stop firefighting every day, and to become a professional construction manager who commands respect, then this course is for you. Take a deep breath. Because from this moment on, you are about to learn the systems and strategies that top contractors and developers use to succeed, and why 90% of projects fail when these systems are missing. This is not theory. This is practical, step-by-step guidance. It is designed for professionals who want results, not guesswork. So, let's begin. Let's take control. And let's make sure that your next project is not just completed, it is successful, profitable, and delivered with confidence. Introduction. Welcome to this complete construction project management course, a professional training designed to give you the knowledge, systems, and frameworks needed to successfully plan, execute, and deliver construction projects of any size. Whether you are a contractor managing a small residential project, a developer coordinating multiple complex sites, or a project manager striving to increase profitability, this course will provide you with the tools to take control of your projects and ensure they succeed. Contractors who manage both small and large-scale projects, looking to reduce errors, improve timelines, and increase profits. Developers overseeing multi-site developments, where coordination, scheduling, and budgeting become exponentially more complex. Civil engineers responsible for technical execution and planning, who need systems to ensure quality and efficiency at every stage of construction. Project managers who want to increase profitability, control risks, and deliver projects on time. Site supervisors and team leaders seeking structured workflows, clear communication, and reliable processes for their teams. If any of these descriptions fit you, then you are in the right place. Foundations of Modern Construction Project Management. You will learn the core principles that govern successful projects, how to set up systems that prevent errors, and how to organize your teams and workflows. Budgeting, estimating, and cost control. You will gain practical knowledge of how to create accurate budgets, track costs in real time, avoid overruns, and maintain profitability throughout the project life cycle. Scheduling and resource management. You will discover how to create schedules that work, allocate resources efficiently, and use proven project management methods like the critical path method and Gantt charts to maintain control. Risk management and mitigation. Every project carries risks from weather delays to design errors, material shortages, and labor issues. You will learn systematic approaches to identify, analyze, prioritize, and mitigate risks before they become disasters. Contracts, procurement, and legal considerations. You will understand how different contract types impact risk, manage procurement strategies effectively, and prevent legal disputes that can drain budgets and delay projects. Site management and team leadership. Managing people is as important as managing materials. You will learn how to coordinate teams, enforce safety, maintain quality standards, and lead projects with authority and clarity. Quality control and safety systems. You will discover how to embed quality control into every stage of construction, ensure compliance with safety standards, and prevent costly rework. Modern construction technology. You will learn how to use advanced tools like building information modeling, BIM, AI-powered forecasting, digital dashboards, and collaboration platforms to make your projects more efficient and transparent. Real-world case studies. You will see practical examples from both residential and commercial projects, analyzing what went right, what went wrong, and how professional systems can prevent failures. This is not just theory. Many construction courses focus on abstract concepts or textbook knowledge. Here, you will get practical frameworks, checklists, and step-by-step systems that are actively used by successful construction managers around the world. You will learn how to design processes that prevent mistakes before they happen. How to use planning and control systems to predict outcomes. How to communicate and coordinate effectively with all stakeholders. How to adapt modern technology to real-world construction challenges. This course will give you a complete roadmap, from initial project conception to final completion, so you can take any construction project and manage it confidently, efficiently, and profitably. Take notes as you listen. Even though this is a faceless tutorial, writing down key points will improve retention. Pause and reflect on how each principle applies to your current projects. Consider how the frameworks introduced here can be implemented in your workflow immediately. Use the case studies as templates for your own project planning and management. By the end of this training, you will not only understand construction management, you will be able to apply it professionally, make informed decisions, and lead your projects with authority. This is a 6-hour course, designed to be detailed, thorough, and immersive. Some sections will be theory, explaining principles and frameworks. Some sections will be highly practical, showing step-by-step processes, examples, and workflows. Each chapter builds upon the previous one, giving you a complete understanding of construction project management from start to finish. Even if you are experienced in construction, this course will give you new perspectives, modern tools, and strategies that can dramatically improve how your projects perform. So, take a deep breath. Prepare to upgrade your knowledge. Prepare to take control of your projects. Prepare to become the construction professional who completes projects efficiently, profitably, and with confidence. From this point forward, everything you learn in this course will help you transform the way you manage construction projects forever. Let's begin. Chapter 1: Foundations of Construction Project Management. Construction project management is the backbone of every successful construction project. Without it, projects quickly descend into chaos. It is the structured process of planning, coordinating, and controlling resources to achieve project objectives efficiently. It is about more than just schedules and budgets. It is about creating a system that ensures quality, efficiency, and profitability from start to finish. Every project, whether it is a small residential home, a large commercial building, or a multi-phase infrastructure development, depends on well-structured project management. At its core, construction project management integrates 5 key pillars. Scope, defining what the project must deliver. A clear scope answers these questions: what exactly must be built? What materials, finishes, and standards are required? What are the client's expectations? Example. Imagine a contractor building a 10-story residential building. If the scope does not specify the type of flooring for the penthouse apartments, the client may later request expensive hardwood instead of laminate. Cost, managing budgets and financial performance. Professional managers monitor costs continuously, rather than waiting until the end to check if the budget has been exceeded. Example, ordering excess materials early might save time, but it ties up capital and increases storage costs. Time, keeping the project on schedule. Key techniques include work breakdown structure, WBS, critical path method, CPM, Gantt charts and milestone tracking, resource leveling and optimization. Quality, ensuring work meets standards. Example, using incorrect reinforcement steel in a structure may not be immediately visible. Without quality checks, the defect may require costly demolition and reconstruction. Risk, identifying, assessing, and mitigating issues. Every construction project faces risk: weather events, design errors, material price fluctuations, labor shortages, regulatory changes. Projects follow a life cycle: concept, planning, execution, monitoring, closure. Project manager oversees planning, budgeting, scheduling, risk, and stakeholder communication. Site supervisor monitors day-to-day construction and reports progress. Engineers ensure technical execution matches design. Procurement team manages materials, suppliers, and contracts. Construction is both technical and strategic. Technical execution and strategic management must align. Structured communication ensures everyone knows responsibilities, issues are escalated quickly, changes are tracked, misunderstandings minimized. Stakeholders must share expectations, timelines, and responsibilities to succeed. KPIs provide objective measures: cost variance, schedule adherence, safety incidents, quality defects, resource efficiency. Example. If labor productivity falls below target for 3 weeks, management can adjust schedules, retrain staff, or reallocate resources. Construction project management ensures scope, cost, time, quality, and risk function correctly. A professional manager prevents problems before they occur. They do not rely on luck or guesswork. Without foundations, small mistakes escalate into major delays, budget overruns, and failed projects. Mastering these principles is the first step toward becoming a confident, profitable, and effective construction professional. Next, we will dive into construction budgeting and cost control to build financial foundations. Understanding budgeting ensures schedules, quality, and risk management are meaningful and projects stay on track. Let's move forward to master budgeting, cost control, and the financial backbone of successful projects. Chapter 2: Construction Budgeting and Cost Control. Construction projects don't fail because of bad materials. They don't fail because of labor shortages. They fail because of poor financial planning. The majority of failed construction projects fail financially long before the first brick is laid. Budgeting is the foundation of cost control. Without it, schedules, quality, and risk management all become meaningless. You can have the best team in the world, but if the budget is off, the project will spiral out of control. 1. Accurate quantity takeoffs. The first step in budgeting is creating accurate quantity takeoffs. These are detailed lists of every material, component, and element required to complete a project, including concrete volumes for foundations and slabs, steel reinforcement quantities, brickwork and masonry calculations, flooring, plastering, finishing materials, and mechanical, electrical, and plumbing items. Errors in quantity takeoffs lead to underestimation or overestimation of costs, both of which are dangerous. For example, underestimating concrete by 10% may require emergency shipments mid-project, raising costs, delaying timelines, and increasing labor expenses. Modern managers use software or digital takeoff systems to minimize errors and improve accuracy. 2. Labor productivity rate estimation. Labor is often one of the largest components of a construction budget. Estimating labor costs is more than multiplying hours by wages. It requires understanding productivity rates for each task, considering crew skill levels, task complexity, site conditions, equipment availability, and weather. For instance, if plastering is estimated at 50 square meters per day, but a crew only achieves 35, subsequent tasks can be delayed and costs inflated. Professional managers track historical productivity data and adjust estimates based on real-world performance. 3. Material cost forecasting. Material costs fluctuate constantly due to market changes, inflation, and supply chain issues. Accurate forecasting requires researching current prices from multiple suppliers, including delivery, storage, and handling costs, and accounting for price escalations over the project duration. For example, a residential project overran its budget by 20% because delivery costs for imported materials were overlooked. With proper forecasting, this could have been prevented. Always include a margin for price fluctuation to maintain financial stability. 4. Contingency allocation. Even the best estimates cannot account for every issue. A contingency allowance is essential, a reserved budget for unforeseen events like weather delays, minor design changes, unexpected site conditions, or small labor or material errors. Most professional managers allocate 5 to 10% of the total project cost for contingencies, depending on complexity. For instance, an unexpected soil issue requiring extra excavation on a commercial building would be covered without financial strain if a contingency fund exists. 5. Cash flow planning. Budgeting is not just about total costs. Cash flow planning ensures money is available at the right time. Without it, subcontractors may remain unpaid, suppliers may hold deliveries, and labor may slow down due to delayed payments. Planning cash flow alongside the project schedule anticipates peaks and troughs in spending and secures financing or credit lines to cover gaps, keeping the project running smoothly. Real-world example. Consider a residential project with a $500,000 budget for a 20-unit apartment building. Imported materials were ordered without including delivery costs, causing actual spending to rise to $600,000, a 20% overrun. Had the manager conducted thorough material cost forecasting, accounted for delivery and handling, and applied a contingency allowance, this overrun could have been avoided entirely. Budgeting is not optional, it is the foundation for every successful project. Summary. Construction budgeting and cost control is accurate, proactive, continuous, and integrated. Accurate quantity takeoffs and labor estimates, forecasting material costs and risks, continuous monitoring and reporting, and integration with scheduling and procurement ensure projects remain on track. Without robust budgeting, projects inevitably overrun, delay, and fail. Mastering this chapter sets the stage for financially controlled, predictable, and successful construction projects. Chapter 3: Scheduling and Resource Management. Importance of time. Time is one of the most critical elements in construction. Delays cost money, frustrate clients, and create ripple effects that can affect the entire project timeline. Efficient time management is essential for success. Scheduling as a control tool. Schedules are not just dates on a calendar. They guide teams, allocate resources efficiently, and prevent chaos by providing clear direction, milestones, and dependencies for every task. Work breakdown structure, WBS. A work breakdown structure divides the project into smaller, manageable components, defining tasks, responsibilities, and progress checkpoints. It creates clarity and accountability at every stage. WBS example. For example, a 20-story building can be broken into phases. Foundations, structural work, MEP systems, finishing, and landscaping, with tasks assigned for every activity to ensure nothing is overlooked. Critical Path Method, CPM. The critical path method identifies tasks that determine the project's duration. Understanding dependencies and minimum completion times ensures that delays are recognized and managed effectively. CPM importance. Tasks on the critical path directly impact project completion. Non-critical tasks may have float, allowing flexibility without affecting the overall schedule. Prioritization is key. Gantt charts. Gantt charts visually represent schedules, task durations, and dependencies. They allow managers to monitor progress and spot potential bottlenecks at a glance. Milestone tracking. Key milestones, such as foundation completion, roof installation, MEP systems, and final inspections, act as control points to monitor progress and maintain project alignment. Resource allocation. Resource management ensures labor, equipment, materials, and subcontractors are available when needed. Efficient allocation prevents idle time and avoids bottlenecks. Resource optimization example. For example, rescheduling bricklayers across different sections can prevent delays, balance workloads, and improve efficiency across the construction site. Float analysis. Float, or slack, is the extra time a task can be delayed without affecting the overall schedule. Understanding float allows flexibility while safeguarding deadlines. Buffer planning example. For instance, concrete curing may take longer in cold weather. Proper buffer planning ensures that subsequent tasks start on time, preventing schedule slippage. Delay mitigation. Managers anticipate delays using strategies like alternative suppliers, task overlapping, workforce adjustments, and shifting non-critical tasks to maintain momentum. Supplier delay example. If a steel delivery is delayed, fast-tracking foundation work and starting MEP planning simultaneously keeps the project on track without halting progress. Real-world success story. High-rise projects using CPM, WBS, and Gantt charts track the critical path and resources daily. This approach allowed the project to finish 2 weeks early and under budget. Real-world failure story. Ignoring float and buffer can be disastrous. In one office building project, rain delayed excavation, schedules were disrupted, and costs soared due to lack of contingency planning. Scheduling software. Modern managers use tools like Primavera P6, Microsoft Project, Procore, Buildertrend, and BIM integration to maintain real-time, accurate schedules and updates. Real-time updates. Integration of scheduling software with field reporting allows dynamic, precise timelines, ensuring adjustments are made instantly to avoid drift or miscommunication. Key takeaway, schedule as tool. A schedule is more than a timeline. It is a management tool that guides teams, controls resources, and ensures timely delivery across every project phase. Key takeaway, WBS. The work breakdown structure ensures that no task is overlooked, responsibilities are clear, and teams operate efficiently with full visibility. Key takeaway, critical path. The critical path identifies tasks that matter most. Delays here directly affect project completion, making it essential to focus resources where they count. Key takeaway, Gantt chart. Gantt charts visualize progress, dependencies, and potential schedule bottlenecks, helping managers make proactive adjustments. Key takeaway, resource allocation. Proper allocation of resources, along with float management, prevents bottlenecks, idle crews, and inefficiencies across the construction site. Key takeaway, delay mitigation. Delay mitigation strategies prepare projects for unforeseen challenges, keeping construction timelines on track and minimizing disruption. Key takeaway. Modern software. Modern software makes schedules dynamic, accurate, and collaborative, linking design, planning, and field execution for optimal project control. Summary statement. Scheduling and resource management are the pulse of a construction project. Controlling time, resources, and cost simultaneously ensures efficiency, predictability, and profitability. Without proper scheduling, projects drift, budgets explode, and teams scramble, leading to inefficiency, frustration, and unnecessary costs. Mastering scheduling. Mastering scheduling and resource management keeps projects on time, efficient, and profitable while ensuring all tasks and resources are optimized. Building foundation for leadership. Strong scheduling lays the foundation for effective construction leadership, enabling managers to guide teams with authority and deliver projects successfully. Chapter 3 Closing Visual. Controlled schedules and resources ensure projects finish on time, within budget, and at the highest quality standards, creating measurable success. Professional confidence. Managers with effective scheduling gain confidence, authority, and respect on-site, commanding operations and guiding teams efficiently. Projects in harmony. Proper resource and schedule management ensures teams work in harmony, avoiding bottlenecks, idle time, and unnecessary conflicts. Chapter 3 Summary. Mastering these scheduling and resource management principles ensures predictable, efficient, and profitable construction projects every time. Chapter 4 Risk Management in Construction. Introduction to risk. Every construction project carries inherent risks, ranging from weather delays and design errors to material shortages and labor issues. Recognizing these risks early is crucial for maintaining control and preventing disruptions. Risk impact. Unchecked risks can escalate quickly, causing budget overruns, schedule delays, and compromise quality. Even minor oversights can ripple across a project, creating significant operational and financial consequences. Identification of risks. Step 1 in risk management is identification. Detect technical, financial, and operational risks early, before they escalate into critical problems. Awareness is the first line of defense against project setbacks. Risk analysis. Step 2 is analyzing risks. Evaluate the probability of each risk and its potential impact. Prioritize critical threats to allocate resources effectively and reduce exposure to the most damaging scenarios. Risk prioritization. Step 3 involves focusing attention on the most significant risks. By prioritizing, project managers can ensure that limited resources address high-impact risks first, preventing costly delays and overruns. Mitigation planning. Step 4 is developing mitigation plans. Implement contingency strategies, identify alternative suppliers, and allocate buffer time to address risks before they affect progress. Preparedness is key to resilience. Monitoring risks. Step 5 is continuous monitoring. Track changes in risk status, update plans dynamically, and adjust strategies proactively to maintain project stability and prevent surprises from derailing timelines or budgets. Weather risk example. For example, unexpected heavy rain can delay excavation. By planning buffer schedules and alternate sequencing, the impact on overall project timelines can be minimized, keeping work flowing efficiently. Material risk example. Late material deliveries, such as steel, can halt progress. Mitigation includes alternative suppliers, pre-ordered backups, and real-time monitoring to ensure crews remain productive without interruption. Labor risk example. Labor shortages can threaten schedule adherence. Managers mitigate this by allocating temporary workforce resources, optimizing shifts, and coordinating tasks to maintain efficiency despite staffing challenges. Financial risk example. Budget overruns are a constant risk. Continuous cost tracking, earned value analysis, and contingency funds allow managers to detect variances early and prevent financial stress from impacting project execution. Risk communication. Clear and structured communication ensures that teams, suppliers, and stakeholders respond immediately to emerging risks, coordinating actions and keeping everyone aligned on mitigation strategies. Risk management software. Modern project managers leverage digital risk management tools to log, monitor, and mitigate risks in real time. These platforms provide actionable insights and maintain visibility across all risk areas. KPI monitoring for risk. Key performance indicators, including safety incidents, cost variance, and schedule adherence, track the effectiveness of risk management, allowing continuous improvement and early corrective action. Proactive versus reactive. Proactive risk management prevents issues before they occur, while reactive management only addresses problems after they have already caused damage. The difference is the difference between control and chaos. Summary statement. Effective risk management ensures projects remain on time, within budget, and maintain high standards of quality. It transforms uncertainty into manageable challenges, safeguarding success. Chapter 4 Closing. Mastering risk converts uncertainties into opportunities, strengthens leadership, and equips construction professionals to deliver projects consistently, efficiently, and profitably. Chapter 5 Contracts, Procurement, and Legal Considerations. Introduction to Contracts. Contracts form the backbone of every construction project, defining responsibilities, obligations, and the legal framework that governs execution. A well-structured contract clarifies expectations for all stakeholders, sets boundaries for risk, and ensures accountability from start to finish. Types of contracts. Construction contracts vary, including fixed price, cost plus, and design-build models. Each type carries unique risks, responsibilities, and opportunities for cost control. Understanding the nuances of each contract type is critical to mitigating disputes and optimizing project outcomes. Contract risk. Poorly defined contracts are a major source of disputes, delays, and financial loss. Ambiguities in scope, unclear obligations, or missing terms can escalate conflicts, making proactive risk management and legal review essential for smooth project delivery. Procurement overview. Procurement ensures that all materials, equipment, and services are acquired efficiently, on time, and within budget. Proper procurement planning prevents delays, avoids idle labor, and maintains the flow of resources necessary to keep the project moving. Supplier selection. Choosing reliable suppliers is a strategic decision. Evaluating supplier history, quality standards, and delivery performance reduces risk, ensures project quality, and prevents costly interruptions in the construction schedule. Purchase orders. Clear and accurate purchase orders are essential to ensure materials arrive on time, meet specifications, and are correctly documented. This minimizes errors, supports accountability, and keeps procurement aligned with project timelines. Delivery tracking. Tracking deliveries in real time prevents material shortages, idle labor, and schedule disruptions. Supervisors monitor shipments, confirm arrivals, and adjust site operations to maintain smooth workflow and uninterrupted construction progress. Legal compliance. Legal compliance includes permits, zoning regulations, building codes, safety standards, and labor laws. Ensuring adherence protects the project from fines, delays, and legal disputes while maintaining professional standards and community trust. Contract disputes. Disputes often arise from unclear contract terms, ambiguous scope, or unmet obligations. Proactively monitoring contracts, clarifying responsibilities, and engaging in early resolution prevents costly stoppages and preserves relationships between stakeholders. Risk mitigation in procurement. Procurement risks can be mitigated by vetting suppliers, maintaining alternative sourcing options, and implementing contingency plans. Strategic oversight ensures materials and services are delivered without interruption, even under unforeseen circumstances. Real-time procurement monitoring. Modern software enables real-time tracking of orders, deliveries, and supplier performance. Managers can intervene proactively, coordinate site needs, and prevent delays, ensuring procurement aligns seamlessly with project requirements. KPI monitoring for procurement. Key performance indicators track supplier reliability, delivery punctuality, and cost efficiency. Monitoring these KPIs allows managers to make informed decisions, adjust procurement strategies, and maintain consistent project performance. Contracts plus procurement summary. Effective contracts and procurement strategies are critical to smooth project execution. They reduce disputes, protect budgets, ensure resource availability, and provide the structure needed for projects to be delivered on time, within budget, and to the highest quality standards. Chapter 6 Site Management and Team Leadership. Introduction to Site Management. Site management is the central pillar of construction project execution. It ensures that every activity on site is carried out safely, efficiently, and according to the approved plans. Effective site management keeps teams organized, resources allocated, and progress measurable, bridging the gap between project design and actual construction. Role of Site Supervisor. The site supervisor plays a critical role in coordinating teams, monitoring daily progress, enforcing safety protocols, and maintaining quality standards. Supervisors act as the link between management, engineers, and laborers, ensuring that instructions are implemented correctly and that the project runs smoothly. Daily briefings. Daily briefings align teams with the day's priorities, highlight critical tasks, and prevent misunderstandings. By discussing goals, potential challenges, and safety considerations each morning, teams enter the day focused, informed, and prepared, minimizing delays and miscommunication. Task assignment and delegation. Delegating tasks clearly ensures every worker knows their responsibilities. Assigning duties efficiently improves accountability, maximizes labor productivity, and prevents bottlenecks. Digital tools and clear communication help supervisors distribute work according to skill sets and availability, optimizing performance. Workforce coordination. Effective workforce coordination prevents idle labor, reduces conflicts, and ensures a smooth workflow. By managing multiple crews performing different tasks simultaneously, supervisors maintain balance across operations, ensuring that each activity progresses without impeding others. Resource supervision. Supervisors track equipment, materials, and labor to ensure resources are available exactly when needed. Monitoring cranes, trucks, and stockpiles using digital dashboards prevents delays caused by missing resources and guarantees that the site operates continuously at peak efficiency. Safety enforcement. Strict safety enforcement protects workers, reduces accidents, and ensures legal compliance. Supervisors regularly inspect the site for hazards, ensure personal protective equipment is used, and implement safety protocols, creating a secure environment where construction can proceed without incidents. Quality control on-site. On-site quality checks verify that materials, workmanship, and assemblies meet the required standards. Inspecting tasks during construction prevents defects, reduces rework, and maintains client satisfaction. Continuous oversight ensures that quality is maintained from start to finish. Conflict resolution. Resolving conflicts between teams swiftly keeps projects on schedule and maintains harmony on-site. Supervisors mediate disputes, clarify roles, and ensure that all teams remain focused on common objectives. Efficient conflict management prevents delays and fosters a collaborative environment. Performance monitoring. Tracking team performance ensures productivity targets are met and delays minimized. Using digital dashboards, supervisors monitor progress, identify underperforming crews, and implement corrective measures. Continuous performance monitoring aligns work output with project timelines and quality expectations. Leadership and motivation. Strong leadership inspires teams, encourages accountability, and drives high-quality results. Managers set the tone for professionalism, motivate workers through clear communication, and lead by example. Effective leadership translates into disciplined teams, consistent output, and superior construction performance. Communication tools. Structured communication through digital tools ensures timely updates, clarity, and coordination across the site. Supervisors use tablets, mobile apps, and dashboards to relay instructions, track progress, and prevent misunderstandings, keeping every stakeholder informed and aligned. Site management summary. Effective site management integrates leadership, safety, quality, communication, and team coordination into a seamless operation. When managed correctly, the site functions like a well-orchestrated system, delivering projects on time, within budget, and to the highest standards of quality, while keeping teams safe and productive. Chapter 7, Quality Control and Safety Systems. Introduction to Quality and Safety. Quality control and safety systems form the backbone of professional construction management. They ensure that every process, material, and workflow meets established standards, while simultaneously protecting the people who make the project possible. Implementing these systems creates accountability, reduces risks, and fosters a culture where quality and safety are not optional but fundamental to success. Material verification. Verifying construction materials before they are used prevents defects, ensures compliance with specifications, and maintains consistent quality. Every batch of steel, concrete, or finishing material must be inspected, tested, and documented. Early detection of substandard materials saves time, reduces costs, and ensures that the project adheres to technical and regulatory standards from the very start. Inspection and test plans. Structured inspection and test plans allow managers to identify errors at the earliest possible stage. By following detailed procedures for testing concrete, structural elements, and system installations, teams can prevent rework, avoid delays, and maintain high standards of quality. This proactive approach ensures that minor issues are caught before they escalate into major problems. Stage-by-stage quality approval. Approving each stage of construction ensures that standards are maintained consistently throughout the project life cycle. By signing off after foundations, structural work, MEP installations, and finishing tasks, managers confirm that every phase meets design requirements. This stage verification guarantees that quality is built in, rather than inspected in after completion. Preventive checks. Preventive quality checks focus on avoiding mistakes before they occur. Simple measures such as verifying steel reinforcement alignment, checking formwork, and confirming material quantities reduce errors during construction. By embedding these checks into daily routines, managers prevent costly delays and ensure continuous adherence to project specifications. Safety protocols. Enforcing safety protocols is essential to protect workers, ensure legal compliance, and reduce the risk of accidents. From proper scaffolding to fall protection, harness usage, and clear signage, a well-monitored safety system prevents injuries and creates a secure environment where teams can focus on productive work without unnecessary risk. PPE, personal protective equipment. Personal protective equipment is mandatory for all personnel on site. Helmets, safety vests, gloves, boots, and harnesses provide the last line of defense against hazards. Supervisors must enforce compliance consistently, ensuring that workers are fully equipped and trained to use protective gear correctly, minimizing the likelihood of injury. Compliance with regulations. Strict adherence to safety and quality regulations is critical to avoid fines, construction delays, and reputational damage. Managers must ensure that certifications, inspection records, and safety standards are always current. Compliance protects not only the organization but also the workers and stakeholders involved in the project. Risk mitigation through safety. Integrating safety measures into every aspect of construction reduces risk and prevents costly accidents. Regular checks of scaffolding stability, secure ladders, and hazard zones identify potential dangers before they affect productivity. Proactive risk management through safety systems safeguards both personnel and project timelines. Worker training and awareness. Regular safety training programs and awareness sessions equip workers to recognize hazards and respond appropriately. By educating teams on procedures, emergency protocols, and best practices, managers build a workforce that actively participates in maintaining a safe and productive environment, reducing accidents and improving efficiency. Monitoring and reporting. Continuous monitoring and reporting are essential to maintain quality and safety throughout construction. Digital tools, checklists, and real-time dashboards allow managers to track compliance, identify issues immediately, and enforce corrective actions. This ongoing oversight ensures that standards are consistently met and that any deviations are addressed without delay. Technology in quality and safety. Modern technology enhances quality control and safety management. Digital checklists, building information modeling, IoT sensors, and dashboards provide visibility into project performance, track risks, and alert managers to potential problems. These tools enable data-driven decisions, reduce human error, and create a safer, more efficient construction environment. Continuous improvement. Reviewing successes and mistakes after each project phase builds stronger quality and safety systems over time. Lessons learned, data analysis, and team feedback allow managers to refine processes, prevent recurring errors, and continuously enhance the standards applied on future projects. Continuous improvement ensures that quality and safety evolve alongside construction practices. Quality and safety summary. Embedding quality control and safety into every stage of construction ensures that projects are delivered successfully, on time, and without unnecessary risks. By integrating inspections, compliance, preventive checks, training, and technology, managers create an environment where high-quality construction and worker safety go hand in hand, setting the standard for professional construction management. Chapter 8: Modern Construction Technology, BIM, and AI Tools. Introduction to Modern Tech. Modern construction technology has transformed the way projects are planned, executed, and monitored. By streamlining workflows, improving accuracy, and reducing risks on-site, these tools allow managers to maintain control over complex operations. From real-time dashboards to advanced digital models, technology provides visibility, accountability, and predictive insights that were previously impossible, ensuring projects run efficiently and deliver consistent quality. Building Information Modeling, BIM. Building Information Modeling, or BIM, enables the creation of detailed digital 3D representations of structures. This technology allows project teams to plan, design, and coordinate with precision, visualizing spatial arrangements, detecting potential clashes, and optimizing workflows. BIM ensures that every stakeholder, from architects to engineers to contractors, works from a single, accurate model, reducing errors and saving time and resources throughout construction. AI-powered forecasting. Artificial intelligence is revolutionizing construction by predicting risks, resource requirements, and potential schedule delays before they occur. By analyzing historical data, current site conditions, and project parameters, AI provides managers with actionable insights, allowing them to proactively allocate resources, mitigate risks, and optimize timelines. This predictive capability turns reactive problem-solving into forward-looking decision-making. Digital dashboards. Digital dashboards consolidate key project information, giving managers real-time data on costs, schedules, labor productivity, and resource utilization. By presenting live updates and visual analytics, dashboards allow decision-makers to identify trends, monitor KPIs, and respond quickly to deviations. This centralized view ensures that all team members are aligned and that project performance can be tracked continuously without delays. Drones for site monitoring. Drones offer aerial perspectives that enhance site monitoring, track progress, and identify potential issues quickly. By capturing high-resolution images and videos, drones provide detailed insights into site conditions, equipment usage, and work completion. Managers can use these visual feeds to verify progress, detect hazards, and ensure that construction activities adhere to plans, improving safety and operational efficiency. IoT and sensors. The Internet of Things, or IoT, integrates sensors across equipment, structures, and environmental systems. These sensors monitor machinery usage, site safety, and environmental conditions in real time, alerting managers to anomalies or risks immediately. IoT enables predictive maintenance, reduces downtime, and supports informed decision-making, making construction operations safer, smarter, and more efficient. Automated equipment and robotics. Robotics and automated machinery enhance efficiency and reduce human error in repetitive or dangerous tasks. From robotic concrete pourers to automated bricklaying machines, technology performs precise work with minimal supervision. These systems increase productivity, maintain consistent quality, and free human labor for complex problem-solving, transforming how on-site construction is executed. Augmented reality, AR, in construction. Augmented reality overlays virtual designs onto the real environment, allowing engineers and managers to visualize progress and detect conflicts early. By projecting 3D models onto scaffolds, walls, or structural frameworks, AR helps teams identify deviations from plans before costly mistakes occur. This integration of digital and physical spaces improves accuracy, coordination, and communication across all project stakeholders. Cloud collaboration tools. Cloud-based platforms enable seamless collaboration among office teams, field staff, contractors, and clients. Real-time sharing of project plans, updates, and reports ensures that everyone stays aligned, decisions are made quickly, and errors due to miscommunication are minimized. Cloud collaboration fosters transparency, enhances accountability, and accelerates the construction process. Real-time reporting. Real-time reporting provides continuous insight into project performance, enabling managers to make quick, informed decisions. By tracking task completion, cost variances, and schedule adherence, live reporting prevents delays, reduces waste, and ensures that corrective actions are implemented immediately. This approach turns data into actionable intelligence that drives operational efficiency. VR training for workers. Virtual reality offers safe, immersive training experiences for construction teams. Workers can practice assembly procedures, safety protocols, and emergency responses in a controlled environment before performing tasks on-site. VR training minimizes risks, enhances skill development, and prepares teams for real-world challenges, improving both safety and productivity. Integration of tech in workflow. Integrating technology into every stage of construction ensures projects are efficient, safe, and profitable. By combining BIM, AI, drones, AR, IoT, and cloud collaboration, managers can oversee every aspect of a project with clarity and precision. This holistic approach connects planning, execution, and monitoring, transforming complex construction operations into streamlined, manageable workflows. Modern tech summary. The adoption of modern construction technology allows managers to anticipate problems, optimize resources, and maintain high standards of quality. Tools such as BIM, AI-powered forecasting, digital dashboards, drones, robotics, AR, VR, IoT, and cloud collaboration give project teams the ability to execute projects efficiently, safely, and on schedule. Embracing these innovations is essential for professional construction management and achieving consistent, measurable success. Chapter 9, Real-World Case Studies, Residential and Commercial Projects. Introduction to Case Studies. Real-world case studies provide invaluable insights into construction project success and failure. By examining actual projects, we can see what works, what fails, and how professional project management systems prevent costly mistakes. Case studies allow us to understand the practical application of planning, scheduling, budgeting, risk management, and technology integration. They show the real challenges construction teams face and how structured processes lead to predictable, high-quality outcomes. Residential project success story. A 20-unit apartment building serves as a prime example of success achieved through modern construction management systems. This project was completed on time and within budget thanks to precise planning, efficient resource allocation, and close monitoring at every stage. The combination of accurate quantity takeoffs, disciplined scheduling, and proactive communication ensured smooth execution, demonstrating how systematic approaches can deliver tangible results in residential construction. Key success factors. The primary factors driving project success were accurate budgeting, effective scheduling, and real-time communication. Budget accuracy prevented financial overruns, while scheduling tools such as Gantt charts and critical path analysis allowed the team to anticipate bottlenecks. Real-time communication between field teams, managers, and subcontractors ensured immediate resolution of issues, eliminating delays. Together, these elements illustrate how professional systems integrate to maintain control and achieve project objectives. Commercial project example. A high-rise office building highlights the power of technology in managing complex construction. Using building information modeling, or BIM, and the critical path method, the project team coordinated 20 floors of construction efficiently. Detailed 3D models, clash detection, and collaborative planning allowed engineers and managers to synchronize work streams, optimize material usage, and reduce errors. The commercial project demonstrates how technology-driven methods scale effectively for large, multi-level structures. Scheduling impact. Critical path management played a crucial role in preventing cascading delays. By identifying tasks that directly impacted project completion and monitoring dependencies, the team was able to allocate resources strategically and respond to unexpected issues without derailing the schedule. Effective schedule management ensures that both critical and non-critical tasks are executed efficiently, allowing complex projects to maintain momentum and meet deadlines consistently. Financial control example. Continuous cost monitoring and earned value analysis kept the high-rise project within budget despite fluctuating material prices. By comparing planned costs with actual expenditures at each stage, managers identified variances early and implemented corrective measures. This financial discipline, combined with proactive procurement strategies, ensured the project remained financially sustainable while delivering the expected quality, highlighting the importance of integrated cost control systems. Residential project failure story. Not all projects succeed. A small residential development failed due to poor communication, inaccurate takeoffs, and missed deadlines. Without proper planning, the team struggled to coordinate labor, materials, and subcontractors, resulting in idle time, cost overruns, and frustrated clients. This failure underscores the importance of structured workflows, real-time monitoring, and rigorous project management systems to prevent small errors from escalating into major problems. Lessons learned from failure. From this failed project, we learned that misplanning, lack of monitoring, and weak risk management are key contributors to project breakdown. Cost overruns, schedule slippage, and client dissatisfaction all stem from avoidable mistakes. By documenting these lessons and implementing corrective frameworks in future projects, organizations can strengthen processes, improve accountability, and significantly reduce the risk of repeating failures. Infrastructure project example. A multi-phase bridge construction project demonstrates success at scale. The team employed real-time dashboards, resource leveling, and proactive risk mitigation to coordinate multiple work streams simultaneously. By analyzing resource allocation, scheduling dependencies, and potential hazards in advance, the project avoided costly delays and maintained consistent progress. This example illustrates how structured management enables large infrastructure projects to succeed despite complexity and uncertainty. Risk mitigation highlight. Early identification of supplier delays and the use of contingency plans prevented costly construction stoppages. Advanced risk monitoring allowed the team to anticipate potential disruptions, adjust schedules, and deploy resources effectively. Proactive risk management ensures continuity, reduces financial exposure, and safeguards project objectives. This approach reinforces that anticipation and preparation are more valuable than reactive problem solving. Technology integration example. The integration of BIM, drones, and augmented reality allowed managers and engineers to visualize project progress and detect clashes before they occurred on-site. Digital overlays, real-time scanning, and collaborative platforms enhanced decision-making, reduced rework, and optimized resource use. By embracing technology, construction teams can streamline workflows, improve communication, and achieve higher precision in both planning and execution. Case study summary. These case studies collectively demonstrate that systematic planning, technology adoption, and real-time project management prevent failures and drive success. By applying lessons from both triumphs and mistakes, construction professionals can refine processes, optimize efficiency, and deliver projects that consistently meet schedule, budget, and quality targets. Real-world examples show that success is not accidental. It is the result of disciplined methodology, strategic use of technology, and proactive management. Chapter 10: Project Closure and Handover. Introduction to Project Closure. Project closure is a critical phase in construction management, ensuring that every project is fully completed, thoroughly inspected, and formally handed over. It establishes accountability, confirms that deliverables meet contractual requirements, and provides structured documentation for future reference. Without proper closure, even successful construction projects risk hidden deficiencies, unresolved tasks, and incomplete records. This stage transforms months of effort into a tangible, professionally delivered asset that meets client expectations and organizational standards. Final inspections. Final inspections serve as the cornerstone of quality assurance, safety verification, and regulatory compliance. At this stage, every structural element, system, and finish is carefully examined. Inspectors and project managers identify deficiencies, confirm adherence to design specifications, and ensure all safety protocols have been met. These inspections protect the client, safeguard the organization, and prevent costly post-handover issues. By conducting comprehensive final inspections, we guarantee the project is ready for operational use and meets both professional and legal standards. Quality verification. Quality verification goes beyond visual checks. It is a methodical review of every system, material, and finish against predefined project specifications. Managers use digital checklists, stage-by-stage inspections, and compliance criteria to ensure that the work delivered reflects the highest construction standards. This process mitigates risk, prevents rework, and reinforces confidence that the project has been executed correctly. From MEP installations to flooring, wall finishes, and structural reinforcements, every detail is assessed and approved before handover. Handover documentation. Handover documentation is the formal record of project completion. It includes as-built drawings, operation manuals, warranty certificates, maintenance instructions, and all legal and contractual documentation. Proper documentation ensures that the client, facilities team, and future maintenance personnel have a complete understanding of the building systems. This archival process also serves as an organizational knowledge base, capturing lessons learned, decisions made, and detailed specifications for reference in future projects. Client walkthrough. A client walkthrough is an essential step in project closure, allowing the client to inspect, experience, and understand the finished construction. Project managers guide clients through the building, explaining operational systems, safety features, and functional aspects of each space. This ensures transparency, reinforces trust, and allows the client to confirm satisfaction. Walkthroughs often uncover minor adjustments that can be addressed immediately, ensuring a smooth and positive final handover experience. Punch list completion. Punch list completion is a process for recording, tracking, and resolving minor deficiencies or incomplete tasks before final acceptance. Items such as touch-up work, small repairs, and system adjustments are documented in a digital or physical punch list. Project managers and contractors collaborate to address each item promptly, ensuring nothing is overlooked. This ensures that the project is truly complete, functional, and aligns with the high standards expected by the client and the organization. Final sign-off. The final sign-off is the official acknowledgement that the project has met all contractual obligations, quality standards, and client expectations. At this stage, responsibility for the building transfers from the contractor or construction team to the client. Project managers often use digital approvals, tablets, and official documentation to confirm sign-off, ensuring clarity and legal accountability. This marks the culmination of the project lifecycle and represents a milestone of professional achievement for all stakeholders involved. Lessons learned review. Lessons learned reviews are structured meetings where teams analyze project performance, identify what went well, and examine areas for improvement. Data from schedules, budgets, risk logs, and quality assessments are reviewed to capture actionable insights. By reflecting on successes and challenges, organizations can refine processes, avoid repeating mistakes, and improve efficiency in future projects. This continuous improvement mindset transforms knowledge into organizational capability, strengthening future project delivery. Financial closeout. Financial closeout is the reconciliation of the project budget, ensuring all invoices are processed, outstanding payments settled, and cost reports finalized. Project managers review actual expenditures versus planned budgets, analyze cost variances, and confirm that all financial obligations are fulfilled. This process ensures transparency, accountability, and prevents lingering financial disputes. Accurate financial closeout supports profitability analysis and contributes to the long-term sustainability of construction management practices. Chapter 11: Advanced Project Management Techniques. In this chapter, we explore advanced project management techniques used by top construction professionals worldwide. These techniques help optimize efficiency, reduce risk, and deliver projects that consistently meet schedule, cost, and quality targets. You will learn methods that go beyond basic planning, giving you strategic control over complex projects. Lean construction focuses on eliminating waste, improving workflow, and maximizing value. It ensures that every resource, time, labor, and material is used efficiently without compromising quality. By removing unnecessary steps and streamlining processes, projects become faster, more predictable, and cost-effective. Integrated project delivery brings all stakeholders together from the very beginning: owners, designers, contractors, and suppliers. This collaborative approach minimizes misunderstandings, enhances communication, and ensures that every decision benefits the project as a whole. The result: fewer conflicts, faster problem solving, and improved outcomes. Critical chain project management focuses on task dependencies and resource constraints. By identifying bottlenecks and prioritizing critical tasks, CCPM ensures that key activities are never delayed. This approach keeps the project on track even in complex, multi-resource environments. Risk is an inevitable part of construction. Advanced risk analysis uses predictive modeling and probability-based simulations to anticipate potential delays, cost overruns, and technical challenges. By preparing for risks before they occur, managers can implement mitigation strategies proactively, rather than reacting to problems after the fact. Earned value management tracks project performance across scope, schedule, and cost simultaneously. EVM allows managers to identify deviations early, calculate cost variance, and understand schedule performance. By comparing planned work to actual progress, corrective actions can be taken before problems escalate, keeping projects on time and within budget. Building Information Modeling, or BIM, integrates design, schedule, and cost data into a single model. Managers can visualize construction sequences, detect potential clashes, and optimize resource allocation. BIM is a powerful tool for improving coordination, reducing errors, and making informed decisions at every stage of the project. Artificial intelligence and predictive analytics are transforming construction project management. By analyzing historical data and real-time inputs, AI predicts potential delays, budget overruns, and safety risks. This allows managers to make proactive, data-driven decisions that prevent costly mistakes and optimize outcomes. Modern collaboration platforms connect office teams, field staff, and subcontractors. Real-time updates ensure that everyone stays aligned, progress is tracked accurately, and issues are resolved quickly. These tools make communication seamless, reduce errors, and increase project efficiency. Advanced project management techniques give you the power to manage complex projects with confidence. Lean construction, IPD, CCPM, advanced risk analysis, EVM, BIM, AI, and real-time collaboration are not just tools, they are systems that transform chaos into control. By mastering these methods, you ensure projects are delivered on time, within budget, and to the highest standards of quality. This is the future of professional construction management. Asterisk. Conclusion. Your journey through construction project management doesn't end here. You now understand the foundations, the pillars of project success, and the systems that transform chaos into control. Remember, every project starts with a clear plan, an accurate budget, and a realistic schedule. Every project succeeds when risks are identified, monitored, and mitigated before they become problems. The professionals who lead successful projects are proactive, detail-oriented, and disciplined. They don't leave success to chance, they create it with knowledge, systems, and smart decisions. From this point forward, every blueprint you read, every schedule you plan, every budget you create, is an opportunity to apply what you've learned. To prevent mistakes. To save time. To protect your profits. To lead your team confidently. Construction project management is not just a skill, it's a mindset. A mindset that combines precision, foresight, and leadership to deliver results. Carry these principles into every project you manage. Continuously monitor, adjust, and refine. Celebrate success when your projects finish on time, on budget, and with the quality that clients expect. And always look for ways to improve. You have the knowledge. You have the tools. You have the system. Now, go confidently into your next project. Lead with clarity. Execute with precision. And transform every construction challenge into an opportunity for success. Because mastery is not about luck. It's about preparation, action, and unwavering focus. Congratulations! You are ready to take control, deliver excellence, and become the construction professional you've always aspired to be.